Happy holiday, Dr. Barsh, and welcome to the Pet Buzz today.
Happy to be here.
So, Dr. Barsh, prior to your research, what did we know about cat color and or color patterns of various animals?
A fair amount is known about changes in color, what makes, say, a black cat or a white cat or a brown cat or even an orange cat. But much less was known about cat color pattern. And so that's where our research, I think, has really made some progress.
What were some basic premises that people knew about color just in general or hair color?
What's known is that the color comes from what's called the pigment cells, melanin, and the cells that produce melanin are called melanocytes. And there's melanocytes throughout the skin and in every hair follicle. And so when you're looking at a cat, you see color. What you're looking at is the color of the hair, but what you're really looking at is the melanin that's produced by the melanocyte that is in each hair follicle.
I guess you and your research team identified a gene that controls coat color in tabby cats. Is that correct?
Well, it's really coat pattern, right? So we distinguish between the general color, whether the overall color is, say, brownish or orangish or, medium gray. We distinguish between the overall color and what we call the color pattern, which is the distribution of stripes or spots and how they're related to one another. And yes, our earlier research uncovered what is sometimes called the tabby gene, and will change say a mackerel tabby into a blotched tabby.
That tabby gene, does that also affect large cats too?
The tabby gene, just like almost all genes in all mammals, they're shared. 95% or more of genes that cats have are also found in humans, and of course, all other large cats as well. And so we have a tabby gene, and not only do we have a tabby gene, but cheetahs have a tabby gene, lions have a tabby gene, and tigers have a tabby gene. And it turns out that the exact same tabby gene in which mutations cause the blotched tabby or classic tabby pattern in domestic cats, mutations in that same gene in cheetahs cause the king cheetah pattern, which is a cheetah that has big stripes and big, really spots on its back rather than small spots. And they also cause tiger stripes to change what's from sort of a normal tiger stripe-like pattern into what is sometimes called a pseudomelanistic pattern, where the dark stripes have gotten bigger and they start to flow together.
I know that you have some follow-up publications from new research that you published in September, I think, in Nature Communications for the continuation of the tabby cat study. But can you talk to us about that research and what it revealed?
Our group is really interested in general in this question of color pattern, not, the general color, but how do the stripes and spots develop? How are they related to each other? And how do they change, say, from a cat to a cheetah to a leopard to an ocelot? And so we've continued studying the genetics, the genes that change, say, one type of pattern into another, and building on the classic tabby versus mackerel tabby work, we were able to figure out what makes the spots get smaller, right? So one of the, when we talk about, say, mackerel tabby versus blotched tabby, the dark spots or the dark stripes get bigger. It's the exact same thing with a king cheetah. But it turns out that there are variants in domestic cats and also wild felids as well, where the stripes or spots, the dark areas, get a little bit smaller. And by studying developing cat embryos, we were able to figure out another gene called DKK4 that makes the spots smaller in, say, an Abyssinian cat.
Why is the Abyssinian cat so important to your research?
Sure. So Abyssinian cats are really interesting. They are described as having what's called a ticked pattern. And what ticked refers to in the Abyssinian is the fact that each individual hair has bands of dark and light pigment. And that's what gives rise to the sort of overall brushed appearance that you see in an Abyssinian cat. You also see that, say, in a lion or a puma, a mountain lion. They have that sort of overall ticked appearance. But it turns out we discovered that there's something else that's going on in the Abyssinian cat. And that's that it actually has little spots, that is, groups of hairs that are darker than surrounding hairs. But those spots are really tiny. They're so tiny that they're just a few hairs that might be darker, lighter than the adjacent hairs. And so that's what really gives rise to that characteristic pattern of the Abyssinian. Not only the fact that individual hairs have bands or ticks of dark and light pigment, but that groups of hairs are different from one another, but they're just very tiny spots.
I guess when you look close up and really start thinking about it, you could probably start to see the pattern, correct?
Yeah, if you and the other way to see the pattern is, it turns out that here's some nerdy genetics for your listeners. The mutation in this gene, the DKK4 gene that causes the ticked phenotype, you need 2 copies to look like an Abyssinian cat. But if you have just 1 copy of the ticked mutation, then the spots are intermediate in size and they're very easy to see. And a great example of that is present in a very rare kind of domestic cat called the Savannah cat, and not only just the Savannah cat, but a kind of Savannah called the Cervaline morph of the Savannah cat.
I don't think that is he CFA registered?
Not CFA, maybe TICA.
What's up with how can you explain the color of white or black cats?
Before I say something about white or black cats, I also want to make a comment about Abyssinians and lions and mountain lions, because remember we were just talking about the Abyssinians, which have these really tiny little dark spots that are almost impossible to see. And so you might say, well, is that why lions look the way they do? Or is that why mountain lions look the way they do? But the answer is no. And we know that because when lion cubs or mountain lion cubs are born, they have big dark spots and those spots go away. So what's happening with the Abyssinian cat is different from what's happening in a mountain lion or a lion.
What about Bengal cats?
Oh, Bengal cats are great. We love Bengal cats because there's so much of the variation in the pattern of the Bengal cats is something that's been developed by the breeders who love these Bengal cats. So we work very closely with Bengal cat owners and breeders. And in fact, we're interested in working more with them.
Will you be finding out how DKK4 paints the array of color patterns domestic cats wear? Because I know that there's more research to be done with that.
Yeah, we want to figure out how DKK4 works together with the tabby gene to control different color patterns. And in fact, this was a great setup for this question, because one of the ways we're doing that is to work with Bengal breeders and Bengal owners who have different arrays, different types of patterns. You know, because some Bengals, they look a little bit like ocelots, but other Bengals look a little bit different. There's a pattern in Bengals called marbled, which is really interesting. And there, in fact, there's a pattern in Bengals where they look like tigers, right?
It's cool. Oh, but we never found out about black and white cats.
Yeah.
So you can tell that, my sort of nerdy genetic self, we love talking about patterns, stripes and spots. And color, I think we know a lot more about color. And so it's less of a mystery. And so we find it a little bit less interesting because we already know a fair bit about it. But the answer is that, remember we were talking earlier about where the color comes from, and it comes from the melanin, which is produced by the melanocytes, which are the cells in the skin and the hair. And white cats, almost all white cats are white because they're missing their melanocytes because of a mutation in a different gene that prevents the melanocytes from developing or surviving. Now, black cats, they all have melanocytes, otherwise they wouldn't have any color at all. But they have a mutation in a gene that's required to produce the different types of melanin, because melanin can be kind of blackish brown, or it can be reddish yellow. And in a black cat, they have a mutation in a gene that prevents the melanin from switching between the black brown to the red yellow melanin.
What should breeders and pet owners take away from your study?
Breeders and pet owners should take away from our study that not only are cats wonderful companion animals that bring a lot of pleasure and reward to people that love them, but they're also something that scientists can learn from. And so, none of this would have been possible without partnering with breeders and owners and shelters who love cats, as we do. One of the best places to learn more about this work is a blog, actually, that I wrote called How the Serval Gets Its Spots. And if you just Google that, How the Serval, S-E-R-V-A-L, How the Serval Gets Its Spots, you'll be directed to a blog that talks about this research and also references the actual paper in Nature Communications.
Let me wish you happy holidays, Dr. Barsh, and thank you so much for joining and sharing that research that you've done with us and our listeners.
Happy holidays to you. We always love talking about our science.
Thanks for viewing our content on Pet Buzz Plus.